So we're going to do the height below the water, calculate the density problem in your AQA higher tier physics paper, paper 2. So we have been given the force acting on the block is 637 newtons. The block is at the surface of the pool, 2.5 meters deep. Gravitational field is 9.8 meters per second squared. I mean to calculate the density of the swimming water. And we'll also been given the dimensions, and apparently these were all in centimeters. So you've got 10 as the height, 10 as the width, and 25 as the length. Now, we know that the block is 2.5 meters deep. So what I've actually done, and I don't know if this was in the case of your exam, because I didn't sit your exam. I'm an A-level physics student, so I haven't seen the paper. I'm just going off what my friends have said. The best thing you could do in this case, if you have a lot of information in words, I don't know if you have a diagram in your exam, you probably did, but it's to draw a diagram, right? So this is the diagram that I've drawn. Obviously, it's very simple. I just drawn like a beaker with water and the block at the bottom of the beaker. So the block is 2.5 meters deep, so let's annotate that into our diagram. So that's 2.5 meters. The force acting on the block is 637 newtons. And the dimensions is 10, 10, and 25. So 10 for the height, so 10 goes there. 10 for the height, 25 for the length, and 10 for the width as well. So 10, 10, 25. Now, we now need to find the density of the water, but we need to use a system of equations to relate that. Now, what do we know? We can find the pressure, which is force over area. But that's not going to help us find the density of the liquid. So we might need to use another equation, like a two-step problem, to solve this. And the other equation you can relate is the higher tier equation, that pressure is equal to the height of the column times the density of the liquid times gravity. Now, first of all, we can't use this equation yet because we don't know the pressure of the column. So we have to use this equation to find the pressure of the column, to then substitute the answer of that into here to find the density. Now, it might seem confusing, but we'll work through it together. So we got pressure is equal to force over area. Now, we know the force acting on the block is 637 newtons. So we can say that force is 637 newtons, but we don't know the area. Now, the area that's acting on, well, it's not acting on this side, because, if you place it underneath the water, the area will be acting on this top section here. Right, so we have to calculate the area of this top section. So it would be the width here times the length. So the width times the length, which is this over here, and that will get you 25. So the area, let's do it back in white. Area is equal to 25 times 10. And that should give you an area of 250 centimeters squared. But that's not good, okay? We don't want centimeters squared. We want meters squared. Because remember, the SI units, you need to convert to meters. Physicists don't like centimeters. We like meters. So we can do instead, we can convert this into centimeters. So 25 centimeters into meters, convert it into meters. 25 centimeters into meters is 0.25. Times by 10 centimeters, but we don't want centimeters, remember, we want meters, so you want to times that by 0.1. These are all in meters, so this will give you meters squared, which will give you an answer of 0.025 meters squared. Now we can calculate the pressure by dividing the force by the area, which is 637 over 0.025. The pressure is 25,480 pascals. Right? Or if you want, you can use Newton per Newton meter squared. That's another unit for pressure, but I like to use pascals. They're both the same thing. It's just the different units which I use. Now you can then substitute the pressure, because we now have the pressure, into pressure is equal to height times density times gravitational field strength. So it will be pressure is height times density times gravitational field strength. Rearranging this expression to find the density, you get pressure is over to height times gravity, which is equal to density. So pressure is 25,480 divided by the height of the column, which we said was 2.5 meters over here, 2.5 meters. So 2.5 times by the gravity, which is given to you in the question, of 9.8. So times the answer by 9.8. And you should get an answer of 1040 kilograms per meters cubed, which is the units for density. And that should be the answer to the problem. And if you want a little self-check, right, we know, well, in physics, we accept that the density of water is 1,000 kilograms per meters cubed. However, in this case, remember, in the question, I believe it asked for a swimming pool density. And in the swimming pool, you use water. And if you notice that these are actually very similar to each other, like it's only 40 more. So we can kind of safely say that that will be the correct answer because they're very, very similar. And you don't fill a swimming pool with, I don't know, gasoline or something. So yeah, so the answer is 1040 kilograms per meters cubed.